Okay, we're going to learn about some chemical bonding here, and I'm just going to start off by saying that the beginning of this is going to sound like a review because it is, but don't turn off the video because we're pretty soon going to get into stuff that's new. Okay, so just stick with it because if you stop, you're going to miss all the new stuff. Okay, so we're going to start with a little like flashback to first semester, but then we're going to barrel on into new stuff. Okay. So we're going to talk about why atoms bond together. And as you might remember from first semester, it has to do with their electrons, okay? And as it turns out, atoms want a certain number of electrons, and I say that it's because it makes them happy, right? But of course, um, atoms don't have feelings, right? But basically what it means is it makes them nice and stable, okay? And everything's trying to gain stability in the universe, okay? So as it turns out, for atoms, the quote unquote right number, the number that makes them stable or happy, is 8. Okay. And the noble gases all happen to have 8. And so that's why they don't bond with anything else. That's why they're the nobility, because they keep to themselves. They already have 8. They don't need anybody else. Whereas all the rest of the periodic table is trying to get to 8. And so they're going to do different things with their electrons to become like the noble gases to make them happy. And those different things is they're going to like engage in some bonding. Okay. So again, this is going to sound familiar to you. Remember, sodium has a number 11, which means it has number 11 electrons, and it wants to be like the closest noble gas to it, right? Closest noble gas is neon, which has 10. So sodium is going to give away an electron, which will give it 10 electrons, okay? And because it gives away an electron, it has +1 charge. Remember, this is our review part right here, okay? So that's what's going to make sodium happy and stable. Whereas something like calcium has, with number 20, has 20 electrons. It's trying to be like the closest noble gas, which is argon, which is 18. So to get from 20 to 18, it's going to have to give away 2. And so that is going to make it nice and stable, and that is going to give it a +2 charge, right? So we are forming ions here. Remember that? Fluorine has 9 electrons, is trying to be like the closest noble gas, which is neon, which has 10. Ooh, so to get from 9 to 10, it's going to have to gain an electron because it's gaining a negative charge. That gives it a 9 minus 1 charge because it's gaining a negative electron, right? So that's going to give it a charge of -1. And phosphorus with 15 electrons wants to be like argon, which is 18, so it's going to have to gain 3 electrons, so that's going to give it a -3 charge. Okay, this is our review portion, right? This should not be anything new or anything like groundbreaking for you all. Okay, so atoms can form ions to give themselves the same number of electrons as the closest noble gas. Okay, and this is called ionic bonding. So here is actually it all drawn out. Okay, so here is sodium with all of its electrons, and here is chlorine with all of its electrons. When sodium gives one to chlorine, that gives it, notice, 1, 2, 3, 4, 5, 6, 7, 8 in its like outer ring or outer circle, because electrons kind of form these little circles. Of course, it's 3D, but they kind of form these little circles around the nucleus. And here's chlorine here. And notice when sodium gives chlorine, that electron, which is now right here, we have 1, 2, 3, 4, 5, 6, 7, 8 in its outermost circle. And no noble gases have 8 electrons in their outermost circle. Aha, see, this is how they become like noble gases here. And here's what it looks like between magnesium and oxygen. Okay, magnesium gives 2 to oxygen. And that gives magnesium, counted up, 2, 4, 6, 8 in its outermost. And after oxygen got the 2 from magnesium, it's got 2, 4, 6, 8 in its outermost. Again, so we got 8 in the outermost. That makes them like a noble gas. That makes them both happy. Okay, so this whole 8 thing, this is called the octet rule. Atoms winning 8 electrons in their outermost circle. Okay. And so, there we were drawing out the electrons and, looking back at here, oh, that's quite a few electrons. But notice the electrons on the inside aren't involved in this at all. It's only the outermost electrons, right? So really, we're just focusing on those outermost electrons, which are called the valence electrons. And to figure out the valence electrons, remember we've got this nice little thing where everything in group 1 has 1, group 2 has group 2, 3 has 3, 4 has 4, 5 has 5, and so on. Remember that? Remember from first semester? Okay, so we're just going to draw out those outer electrons and not get to the inner electrons, but knowing that they're going to do something with their outer electrons to get them to 8, that octet rule. And we're going to draw them with dots. All right, so this is like a basic review of ionic compounds, is they are going to give or take electrons to give their outer circle 8, which makes them like a noble gas, which makes them happy. The plus charge and the minus charge will whoop, like smush them together like magnets, and that is an ionic bond. Okay, so that was kind of like a nice review of first semester ionic bonding. Now we're going to get into another kind of bonding. Okay, so atoms are still going to want the octet rule, 8 electrons to be like a noble gas. Okay, let's look at chlorine here. So chlorine's in group 7, so it has 7 valence electrons. We could draw it like this. And if there's another chlorine, we could also draw it like that. Okay, how are they going to become happy? Does it make sense that if this chlorine gives away this 1 electron over here, now this chlorine has 8, so it's happy. But if we were to take like a finger and just cover that mentally, that would give this chlorine only 6, so it wouldn't be happy, right? So if chlorine just gives 1 away, that would make 1 happy, but the other 1 unhappy. So that's not going to work. Giving and taking is never going to get these two to both be happy. As it turns out, instead of giving and taking electrons to form a covalent bond, they're going to share electrons. So let's see how this works here. Basically, these 2 chlorines decide, hey, let's take these 2 in the middle and let's share them, okay? And so if we look down here, this chlorine on the left, if you count that shared pair in the middle, now has 8. And then this chlorine on the right, if you count that shared pair in the middle, now has 8. So the octet rule is there. We draw this by drawing a dashed line in between them to show the bond that is formed. So there's the bond. And a bond is always made up of 2 electrons. So 2, 4, 6, 8. 2, 4, 6, 8. Let's look at oxygens. Okay, we've got 6 is in group 6, 6 valence electrons. Another oxygen would also be in group 6, 6 valence electrons. Well, similarly, if it wants 8, that means this one's going to have to gain 2. So if this guy gets 1 from here, 1 from here, he'd be happy. But now this one would only have 4, and that does not make it happy at all. So it's not going to be ionic. The only way that they are going to become happy is if they share, okay, covalent bond here. So let's take a look. Let's say they decide to share a pair of electrons here in the middle. Let's count it up. 2, 4, 6, 7. 2, 4, 6, 7. They're closer to being happy, right? Back here, they each had 6. Here, when they share a pair, they have 7. Oh, but how are we going to get them to 8? As it turns out, they're going to share more than a pair of electrons. They're going to share 2 pairs of electrons, and that is called a double bond. So here we go. 2, 4. The top pair is 6. The bottom pair is 8. 2, 4, 6. Top pair, 8. Okay, and the way we would draw that would be 2 dashed lines in between them. So if they need to draw share multiple pairs, we would draw that as multiple dashed lines. Okay. So again, we've got a single covalent bond is 1 shared pair of electrons, and a double bond would be 2 shared pairs of electrons. And we can even have a triple bond where they shared 3 pairs of electrons, but there's no such thing as a quadruple bond. So it just goes as high as a triple. Okay. The one last type of bonding we're going to learn about is called metallic bonding. Okay. So remember that like octet rule thing and how metals, but the thing is metals always form positive things. Okay. And if we've got a metallic bond, that means all that's present are metals. So how are we going to get all these like positive things to bond together? Well, as it turns out, metals kind of do something entirely different. If we were to look at metals, right, they're giving away electrons to make themselves happy, but these electrons just kind of are free floating here in the middle. Okay, and as we know, opposites attract. So the positive like ions are going to be attracted to these negative free floating electrons, and that's what's going to bond. If you just have like a hunk of copper, that's what's going to bond all these coppers together. Is basically they've got these like negative electrons kind of floating, swishing around in between all of the positive ions. And so it's kind of got this sea of electron theory. Okay, so notice we're not giving, we're not taking, we're not sharing. They're kind of just all pooling them together, and all of the electrons just kind of mill around and float around, and the opposites attract. The positive negative thing kind of holds it all together. Okay. If you remember back to some of our metal properties, the fact that they can be molded into any kind of shape, the fact they can be put into wires, the fact they conduct electricity can be explained by this, right? Since all those electrons are like free floating in the middle, electricity can freely pass through them because electricity is just electrons moving. So electrons are going to be able to move really, really easily. And also with ductility and malleability, right? Being able to bend and shape them certain ways. You're going to be able to pound them into sheets and draw them into wires because of the fact that those ions are going to easily slide past one another. And so that's going to mean it's not going to break, whereas some other things are going to break because we kind of got this floating sea idea. Okay. I know it's kind of weird, kind of different, but that's what they do. Metals are a little bit funky that way. So, just to summarize, we have um, covered ionic bonding and what atoms do with their electrons and how they get to the octet rule. We've covered covalent bonding and what atoms do with their electrons to get the octet rule. And we've covered metallic bonds and how those are different, but still allows them to bond together.